And now how to solve an exponential equation. Solving an exponential equation is very similar to solving a logarithmic equation. It just means that when we get to step 3 and we're changing, we will change it into log as opposed to out of logarithmic form. Before we get started, an exponential function will look like this. A number to the power of x equals an answer. And when I'm talking about behind, I am talking about anything that is behind the x. And when I'm talking about in front of, I'm talking about anything that is in front of the a. A lot of students mistaken the a for a front number, but it does have to be something in front of that. Other than that, we have the same 4 steps, and you're going to see a lot of the same instructions. I only have 4 examples this time, so it should go a little bit faster. So for example number 1, we're going to start with behind. First, find out where the function is, and then you can check behind. So yes, example number 1 does have a behind number. To get rid of the -5, we will add 5 to both sides. That will become 3 to the power of x equals 7. Then we will check in front of. I do have a lot of students that mistaken the 3 as a front number. That's not a front number. There has to be another number in order for there to be a front. So there is no front, which means I can move on to step 3, which is change. Change is when the arrows come in. Keep in mind that we are putting it into log form this time. So we're going to write log. The 3 becomes a baby number, followed by 7 equals x. You are going to need a calculator at this point. Desmos works just fine. I'm plugging it into my TI, and I get 1.771. If I haven't said so yet, please remember that I have a 3 decimal minimum. So when you write it down, you want to go to at least the 3rd decimal. If you want to go further than that, be my guest. Now that the x is by itself and I've solved, I'm finished. Example number 2. I am going to first check to see if there's a number behind my function. Now that -2 is part of the exponent, so it gets included as part of the function. So when I'm looking behind, I will be looking to see if there's any other numbers that are hanging out behind, and there are not. So then I move on to check for the front. This is an example of what a front number looks like. I have the base number and an additional number. So this is a front number. And remember, a lot of students accidentally subtract front numbers when it really should be a division problem. So let's divide both sides by 2, and that will get rid of our front number for us. Step number 3 says to change. So when I get my arrows ready, please remember that we are changing it into log form. So you want to make sure you write down the word log and then rearrange your numbers. Step number 4 is solve. You are going to need a calculator to calculate log base 5 of 2. I'm using my calculator and it comes out to be 4.3. I'm going to round that up to a 1. Again, 3 decimal minimum. And you do want to note that we're not done in this case. The x is not by itself. So in order to get the x by itself, I will add 2 to both sides. And now I am finished. Halfway there, keep it up. Okay, again, starting over. I'm going to find my exponential, which is right here. The -4 is not part of the exponential, therefore it is a behind number. To get rid of the behind number, I will add 4 to both sides. That will give me a 5. I check to see if I have a front number. Remember, the e does not count as a front. There has to be another number in front, and there is not. So I can move on to step 3, which is change. I will get my arrows ready. Remember that we are turning it into log form, so I write down log, and then I can rearrange my numbers. One other thing that we've been working on this week is log of base e. We want to start recognizing log of base e as being the natural log. And I will change that before I start calculating. Now I'm going to go to my calculator, find out what the natural log of 5 is. I note that the x is not quite by itself yet, so to finish this problem I will divide by 2. And I get 0.80, I'm going to round that up, but rounding is not an issue as long as you have 3 decimals. Okay, one more. This particular problem is special because you have an exponential here multiplied by another exponential. This is unworkable. We need to condense those two exponentials into one exponential. And we are going to use the product rule. The product rule allows us to connect addition to multiplication. So even though this is a multiplication problem, when I condense it, it's going to turn into an addition problem. So I've got this x over here, added to, I'm going to add this exponent over here. So I can take it from being two different exponentials, and I can make it into one exponential by putting a plus sign between the exponents. Now I am going to simplify that one step further before I continue my solving process. These two are like terms and can combine to become a 4x, and then the plus 5 will carry. Now that I have condensed my two exponentials into one, I can continue with my process. I will find my exponential, and I will check behind. No, there is no number behind. I will check in front of. No, there is no number in front of. So I can work on converting. We are converting it into log form, so please make sure you write down the word log. And then rearrange your numbers accordingly. We will now need a calculator. Log base 2 of 100 should come out to be 6.643. And the only thing that's stopping me from finishing this problem is I now need to get the x by itself. But that's using stuff that I've been working on since middle school. I'm going to start by subtracting 5 from both sides. And then I can divide by 4. And that should get me 0.41, I'll round that up to a 1. And that is how you solve an exponential.